What's up, YouTube? This is Mike here, the Transforming Toy Box, bringing you a rather interesting review. This review, first of all, was requested by Moco806. He wanted to know a little bit more about the slide rule. I believe I showed it in one of my earlier Transformer reviews, and he wanted to see it up close and personal. So, in order to discuss the slide rule, it really would take far too long to give a truly exhaustive idea of the theories behind the slide rule, but we can at least give you a basic history. Now, this is the Pickett slide rule. I believe this was made in the, I want to say 60s. I believe this is a 60s device, because after that you started getting calculators. Well, this is a calculator. I want to say one thing quick. Then, this is a calculator, just the same as those little things you hold in your hand and push buttons are calculators as well. But this is an analog calculator, as opposed to those being digital calculators. Digital has all the computations going on inside the machine, whereas this one works with your brain to determine the solutions to problems or just figuring out some of the more quirky laws of mathematics. So let's just go into a very basic history. Slide rules. In 1614, John Napier discovered the logarithm, which made it possible to perform multiplications and divisions by addition and subtraction. Doesn't seem like much, but this actually really gives rise to the scale that we're going to see that will form the slide rule. This was a great time saver, but there was still quite a lot of work required. The mathematician had to look up two logs, add them together, and then look for the number whose log was the sum. Edmund Gunter soon reduced the effort by drawing a number line in which the positions of numbers were proportional to their logs. Proportions are one of the major driving forces of the slide rule, as well as the use of logs. The scale started at 1 because the log of 1 is 0. So basically, when you're dealing with logs, you're going to want to start at a number relative to the beginning of a number line, of a regular number line, which is of course 0. So 1, 0. It's same as this back in the 1600s. Same rule applies here. Starts at 1. Everything starts at 1. The scale two numbers could be multiplied by measuring the distance from the beginning of the scale to one factor with a pair of dividers, then moving them to start at the other factor and reading the number at the combined distance. So basically, what you would do is take the log of both numbers, measure the combined distance, and then figure it out based upon both factors. This is where it starts to get a little bit interesting, though. Soon afterwards, William Oughtred simplified things further by taking two Gunter's lines and sliding them relative to each other, thus eliminating the dividers. So rather than having to move out to one distance, move out to another distance, and then figure out the two factors and get the product of them, you could have two lines that would slide across one another and then link up to show your factors. Now, we're not there yet. We're not there yet. I know you're excited, but we're not there yet. Okay. In the years that followed, other people refined Oughtred's design into a sliding bar held in place between two other bars. Oh, now we're getting somewhere. Circular slide rules and cylindrical spiral slide rules also appeared quickly. The cursor appeared on the earliest circular models, but appeared much later on straight versions. By the late 17th century, the slide rule was a common instrument with many variations. It remained the tool of choice for many for the next 300 years. By the way, I mentioned a cursor. This is the cursor. You need both in order to make things happen. While grade 8 slide rules were not particularly intuitive for beginners, this is a very, very interesting thing, just because often we find it easier to do things we're in a digital age here, people. We don't think about the analog style tools anymore. But I'll tell you, when your batteries run dead and you don't have any way to recharge them, right here, people. Some interesting thoughts from a 1960 Pickett manual said, when people have difficulty in learning to use a slide rule, usually it is not because the instrument is difficult to use. The reason is likely to be that they don't understand the mathematics on which the instrument is based, or the formulas they are trying to evaluate. Some slide rule manuals contain relatively exhaustive explanations of the theory underlying the operations. In this manual, it is assumed that the theory of exponents, of logarithms, of trigonometry, and of the slide rule is known to the reader, or will be recalled or studied by reference to formal textbooks on these subjects. So, it's saying that we have to assume, when using a slide rule, that the user understands these basic laws of logarithms, trigonometry, exponents, basic theories. Is what it has to make assumptions. It really does, because the slide rule really is only half of your toolkit. The other half is right up here. There was a somewhat different opinion expressed by a Stanley manual in 1948. The principles of logarithmic calculators are too well known to those likely to be interested for it to be necessary to enlarge upon the subject here. Especially, it is absolutely unnecessary to have any knowledge of the subject to use the calculator. Remember, this is still a calculator, analog though it be. Anyone can calculate with the fuller after a brief study of the following instructions, without any mathematical knowledge whatsoever, and a lot of the time that's true. A lot of the time, all you really need to do is understand the basic principle that you move one index or another across to locate, say, your first factor. On the C scale, you got the 1 starts at 3, you move it to 3, then you move this cursor, which has a little red line called your hairline on it. Say, move it over to 2 right here, and boom, move down and you got 6. Alright, of course there are graduations along the slide rule, which allow for decimal points, which also allow to increase your numbers by tens, by hundreds, by thousands, whatever you feel like. There's another interesting quote from the same Pickett manual. A computer who must make any difficult calculations usually has a slide rule close at hand. Good for difficult calculations, but it does have to be said that a 1960 computer was still understood to be a person who computed. Remember everyone, we humans are the original computers. We make the calculations happen right up here. Now, it does help for digital things to do the work as well, but never forget that you have your own computer right trapped up there in your cranial capacitor. By contrast, a recent dictionary begins the only definition of computer with an electronic machine. Of course, that's just how it's going to be anymore. So there's your basic history. There are some slide rule terms. I'll leave the link for the website that I'm getting this information from. And, of course, always interested in any questions you may have concerning the slide rule. I'll do my best to help you. So, there's just some basic history, what the slide rule is, what it does, why it exists. There you go. Again, link for the website right down there. Some great information here that really will help you understand basic mathematical theory. Thanks for your time, everyone. Thanks for watching. It's been fun. Later. you.